go over homework 3, fundamental statement. And so I'm just going to skip these because these belong to problem 3. So these are 4 problems that I did. So in the first problem, it asks us to read 10 numbers and only display the unique numbers. So essentially, it's going to ask me, can you give me 10 numbers? And if I said like a number twice or more than that, basically only one time the first occurrence of that number should be stored. And so I will demonstrate this later of what it looks like, but for now let me explain the code. So I created nums, which is an array with a type of int. And I did this because I just wanted, I wanted to test, I haven't used this before, so I wanted to test it out. And so num is this variable here just stores the user's input of what number they want to store. And so I ask them, hey, can you just give me 10 numbers? It will store it for us. So there's actually a nested for loop going on, so I'll explain the purpose of it. This for loop, essentially, it will, ask. Well, it doesn't ask, but essentially the user will input a number 10 or a number like 10 times, and it could be a different number. It's fine. The logic will be held later, but that was the purpose of this for loop. It's just getting 10 numbers from the user. And so now jumping down to line 36, the boolean called is there. It's set to false, so it just helps us to check if the number already exists. If it does, we won't add it to the array, but if it doesn't, it's brand new, it's unique, then yeah, well, let's go ahead and add it. So this is how it reads. So this for loop just helps us. So I notice the difference in this for loop versus this for loop. I did use like size underscore t, and this means that is the unsigned integer type and it's safe. I just wanted to play around with it because I've never used it before versus this, but it is supposed to be better because it's safe. Alrighty, so nums.size is the size of the array of nums. In this case, it's whatever, so it would be 10, right? And so it does this. Hey, our current array nums, can you check at j equals 0 to the first index of that array? Is that matching the number that the user gave us? If true, if this is true, then is there is set to true. It breaks out, that means a number already exists. Then, because is there is changed to true, it will not, this condition will not run because it failed here, because is there is true, so let's make it false. If we have false here, it won't run. But now let's say that the number wasn't there, it's brand new, it's unique. Then at the second index, which means j equals 1, at j equals 1, hey, let's say a number is 2. Is the number that the user input equal to 2? Okay, no, it's a brand new number. I'm going to skip this if statement. Break out. Well, it runs 10 times. Anyway, and then comes here and actually runs this guy, because is there is false, false making it not is true. This makes this condition true, and then that means that number will be added to the nums array. And so here, the aim of this is just simply just to print those unique numbers in the array. So if the number entered like 2, 3 times, then the 2 should only appear once. So let's go ahead and actually run it. So let's go ahead and give it some 10 numbers. 1, 2, 3, 4, 4, 4, 4, 5, 5, 5. So I've only entered like 1 through 5, and only see 1 through 5 should appear. So that's perfect. So we're going to go on to problem 2. Problem 2 asks us to, generate 100 random integers between 0 and 9. And this essentially should only be run like 100 times. So what it's saying is like, okay, let's say we have a dice. And the dice has numbers between 0 to 9. I roll it the first time, it gave me a 5. I roll it the second time, it actually gave me another 5. So that means when we print this, at the end of like the 5s got rolled twice, and the number of rolls should add up to 100. That's all that this problem was saying. And so going into it, I went and created an array with a fixed size at 100, not 100, 10, and it's called occurrences with the type int. And so again, this only stores the number of occurrences, because I didn't bother to store the indexes because I could literally, when I print it, I could just print the index starting at 0 and up to 9, and then, just have, at like, zeros, colon, and the number of occurrences by accessing the occurrences array. Um, Great. And so when I noticed when I wrote this code is that I was getting the same number, like I rolled a 6 7 times, and I kept getting that, those set of randoms like every single time I ran this code, and that's not truly random. So I want it to be really random. So every time I run this code, I get different numbers between 0 to 9s, and that, this line allows me to do that. And I pulled it from like a package from C++. Okay, so let's get into this bad boy. So I have this fancy for loop that gets run exactly 100 times, and I know because by the end of it, I actually print out the total occurrences, because at the end of each loop, I incremented occurrences, and then I print it out later. Anywho, so line 74 allows us to randomly generate a number that's between 0 to 9, and this rand method actually came from a CSS plus library called this, and I attached it in above here. You see that? Okay, so this randomly generates a number, and here, let's say, here actually just updates the dynamic rate to the number that it generated, and it increments it by 1. So let's say, I rolled, you know, 5, for example. So at the 5th index, it will get incremented, and then, or really the 6th index will get incremented, and then it will go into the array. Hey, 6th index, which is number 5, can you increment the number of occurrences? And it bumps it up by 1. And this just displays that we've already talked about it, and this is my safety check to make sure I've actually rolled it 100 times, because previously when I was testing it, it was like rolling 1 0 1, and that's just one too many rolls. And so I already generated it. There's not much user input, so it's already automatically generated. So I get 0 12 12 8 8. There's a lot of 1s and 2s. So previously I ran it, and it looks different. For instance, let me if I find one. See, it's 12 times for 0, 14 times for 1. See, it's truly generated randomly. And so for problem 3, essentially I have the aim of this is just wants to sort students by descending order of their score. So the highest ranking or the student that scored the highest will be listed first, and then the student that scored the lowest be listed last. And so it asks us, we need to ask the user how many number of students they want to enter. And so later I ask, hey, how many students do you want to enter? And then there you go. That's where we get that value, and it gets stored into here. Now, student counter, this gets helped because later I decided to use a while loop to be fancy, and I wanted to make sure I know where we at, and essentially it's an index is all what it's doing. It's an index. Hey, what number are we at for the students array, and this is an array of type student. Create a struct called here where it has only 2 traits, which is student name and student score. Student name is a string, obviously, and the student score is an int. And so this array only stores with the type student. And I created this while loop, so as the person is entering the number, so when they enter, like they say, we're entering 3 students, the counter should be set to 0. So this is running because 0 less than 5, sorry, I said 3, right, students. We're entering 3 students, and is 0 less than 3? Yes, that's true. So it enters, you have to enter the student's name and their score. And so this line, what it reads is that the inputted, say, hey, from my students array, at my student counter, which is just the index, let's say we're starting at the first, we're entering the first student's name and score. So 0, since it's set to 0, at the 0 index of student, get their student name, update it to whatever the user wanted to input for this line, and then same thing with their score. Great. Then we increase student counter, and this helps us again to be our index. And so at one point, if this student number is greater than or equal to the nums of students, then it'll just break out of this while loop. And then, so this guy right here, line 114, this sort is a built-in function coming from algorithm from C++ library, and it has three parameters where it says students.begin function, students.end. So this is the array that where it begins and the array that ends, same array. And we created this compare student score function, which is listed on the top here. And so you have to pass two students with the type student, okay? Check their student score by accessing the dot student score. And is student score A, the first one that you put, the first one that's passed in, is it greater than the student B score? If that is true, it returns a true, because it's a Boolean, that's what it returns, true. And then this essentially awesome built-in function helps sort it for us. So that's how you do it. And so let's just go ahead and test this bad boy, because essentially this part is just printing the array of students by accessing their I-index. And so I'm going to go ahead and show you here. Let's say there's 3 students, and we want to do Alex, who scored 100. Okay, and then let's do Tom, that scored, let's say, 30. And then let's say Mel scored in the 50s. So descending order should be 150 and then 30, and that's what it says, 150 and 30. Perfect. That's exactly what I wanted. Okay, and so now we're going to enter the last problem. So problem 4 is kind of separating to almost 3 parts. I've combined part B and C. And part A, essentially, what it wants us to do is to basically get a number, 1 through 100, get the program to guess my number that I'm thinking of. It has to, remember again, be 1 through 100. And then if the computer guessed, so essentially the program has to, so the user has to guess the computer's number. Now, if the computer has a number 50 and I've guessed, 30, then it's going to tell me, hey, you guessed too low. If I say now 100, and again, the guess is 50, that's too high. And then it's supposed to help me keep track at the end, like the number of guesses that I've made just to guess the correct number, okay? And so to do that, I have a user variable that stores my user guess. And then this is the random, again, I've already explained this, helps generate random numbers each time. And this is basically creating the computer's guess, which is the random num. And this is guessing from 1 through 100. And then number of guess counter, I start at 1, because you make the first guess, and regardless if it was right or wrong, you still had one guess. And so I created a do while loop. Essentially, this ensures that making sure that the user is in fact, guessing between 1 and 100. And this is basically saying, making sure that you gave me an int and not like a character. Okay. So when this gets run, it's going to ask, hey, can you guess the number that I'm thinking? I went ahead and commented this out, but originally I commented in when I was debugging to making sure I'm guessing the computer's right number. I can go ahead and comment it for you guys just to demonstrate it. We won't normally see this, and it will still run everything fine. This is just a simple print statement. And let's say I was a good girl and I actually listened to the instructions, and I randomly picked a number between 1 and 100. Great, exit it out, because this is not true, so I break out, and so now I'm in this while loop. And so I say, hey, is the number that I guessed not equal to the random number? Meaning, did I guess incorrectly? Yes. Okay, I'm back here. I got to guess again. And then when I guess again, depending if my number was too high, then it will tell me, hey, your number was too high. Can you guess again? Increases the number of guess counter. Okay, now let's say my guess was low, okay, less than the computer's guess. Then it's saying too low for me, and then again I increased my guess because I messed up again. And then let's say by the fourth time, dang it, I got it, the user's guess does in fact equal to the random num. And that means it'll print, hey, yay, you guessed the number correctly. And it breaks out of this whole while statement. And then it just told me, hey, this is the number of guesses it took you to guess. And that's it. Okay. I comment this thing back in, but I've already ran this code, so it's this. You're not going to be able to see the computer's guess. So let's say, um, I will tell you. Okay, I'm generating a number. I'm going to say 50. Okay. Okay, it was too high. Let me do 25. It's too low. Let's go with like 30. Okay, it's still too low. Let's do 40. Okay, let's do 45. Okay, let's do 44. Let's do 43. And it was perfect. It guessed me 7 times. Okay, great. Now part B and C. And so B and C simply ask us to modify the same program that we were doing. So we're playing the same game, except it's slightly different. Instead of the computer, we're trying to guess the computer's number, it's the reverse. I'm trying to guess the computer's number. The computer's trying to guess my number. And I tell it if it's too high or too low. And we have and then that's part B. Part C right here is that the computer has to guess it 7 times. Okay, so we're on part B and C, and so I'm gonna explain the code. I have basically. Okay, I'm going to explain the code. So basically, I have an int user and a string. So the user number is a number that I'm storing I want the computer to guess. And then this is me telling the computer, was it right or not? The guessed correctly is equal to false. So basically, this is a Boolean value that we tell the computer that did it guess correctly, yes or no. If it's false, I mean it didn't. If it's yes or true, then it did. And I have a ternary operator to do that for me. Anywho, so to make sure, I make sure that the computer is guessing within 7 or less times, I have a high and low bound, and it gets adjusted accordingly depending if I made of a too high of a guess or too low of a guess. So that changes throughout the code to egg the computer on to make sure it's getting the 7 or less guesses. And so by default, no matter what, each time the computer is going to guess 50. Okay, because our number is between 1 and 100. And then I didn't really use, I used it. This is me telling, hey, was it too high? Then if I wrote high, that means the computer guessed it too high. If it's too low, guessed it too low. And this is the number of a guess that it took the computer. Again, we're trying to make sure we get to 7 at most, less than 7 at least. And this is like, hey, my guess is this is the computer's guess. And then I'm going to tell them, hey, was it right or no? If it's correct. If I say yes, that means this guess correctly set to true. It gets run, and then the number of guesses increased by 1. And it gets run only this first condition here, which was like, was it guessed correctly? Yes. Then yeah, I got it right. He only took 1 guess to do it. Now let's say he was wrong, right? I said no instead. The guess correctly is false. This gets run. And it's like, hey, well, the guess correctly, since it's false, it's not, so it makes it true. So we enter this while loop. And then it's like, hey, is it too high or is it too low? I tell it, these are my only options, high, low, or correct. I say it's high. Then it's like, oh, my number is too high. Okay. It changes the high bound, and it takes the computer number and it's just subtracted by 1, and that adjusts it by the high bound. So let's say my number was 40 and it guessed 50. Hey, that's too high. Then the new bound will be 50 minus 1, which is 49. So now the highest it can be would be 49, and it would start to decrease. So I'm halving each time it's guessing. And same thing happens to the low. Same thing, just with low, and instead of minus 1, the computer's number, then it adds 1. But let's say they guessed it correctly, then this else condition will run, and if it guessed correctly is equal to true, it'll break out, and this is guessed correctly, and then it increments it, and then it's done, right? So it did its job, it guessed my number. But a saying that didn't, guess my number correctly, let's say it was too high, gets out of this, goes here, increments it, its new number, it recalculates its new number that it's guessing, and it say, hey, my new number is this. And this just prints out, and say eventually got the right number. This just prints out the number of guesses, and that's it. So let's say my guess is 50. I'm just going to say 80, okay? So is it correct? No. It's just too low, okay? My new guess is 75. Is it correct? Okay. Is it too high or too low? Is it correct? It's still too low because I'm guessing my number is 80, so I'm going to say low. Okay, now that's high, and that is still high. And so now that is still too low. 79, no, mine is 80, low. Correct. How many guesses? Took them 7 times. Okay, and I tried out each condition, and that's basically true. Alrighty, thank you so much.